Welcome back to Agentic Advantage, FIRtech's webinar series on agentic solutions for the enterprise. Welcome to episode 2. Now, in episode 1, we spoke about agentic solutions on a very high level. We looked at the UCK, or the Unified Cognitive Kit, and the various components that go into an agentic solution. I think a few things to realize is that the concept of agentic solutions is quite a difficult one to grasp. The reality is that in a few years from now, we will have agentic solutions running around all over the show, all over the digital cosmosphere, running our business processes, making decisions, driving business outcomes. It feels like far out in the future, but it's really around the corner. Now, although this concept might be very foreign to a lot of us, if we take the various aspects that make up agentic solutions and we use those as building blocks to create this full picture, soon we'll all have a decent understanding of what makes up an agentic solution, how to identify it, how to understand it, how to describe it to colleagues. So in this episode, we're going to dive into one of these aspects specifically, and this is the perception aspect. Now, perception is an agentic solutions view into the real world, more specifically into documents. Now, agentic solutions can be extremely smart. They can be well set up with reasoning and guardrails and context grounding and all of these things. But if agentic solutions can't see the real world, for example, documents, then they become pretty useless in a lot of the different business cases and use cases that we want to apply them. So today, we will be looking at what is generally referred to in the industry as IDP, or Intelligent Document Processing. Now, just a disclaimer up front, IDP is not agentic, and agentic is not IDP. In exactly the same way that you expect your accountant to be able to see and read documents, but the fact that the accountant can see and read documents does not make it an accountant, and it does not give that accountant the ability to work on your systems, to make decisions, to end up registering invoices. So we'll be very much focusing on the seeing, reading, and understanding components when we speak about IDP today. Now, I think a second point to land in this regard is that a lot of organizations run IDP solutions independent of agentic today, and they do so very successfully, and they will keep on doing so for quite a long time to come. So intelligent document processing solutions, or IDP solutions, can stand on its own. But when you combine this with the capabilities in agentic, it takes everything to the next level. Hopefully, as we go through the details today, we'll get to understand the distinction, we'll get to understand where IDP starts and ends, and how it integrates and works together with agentic. Now, in a lot of conversations that I regularly have, I hear that OCR comes up a lot, and it often creates confusion between what is OCR, or optical character recognition, what is IDP, and where does the split come in. Now, OCR is the foundational technology where all IDP solutions started. And OCR, like I just alluded to, stands for optical character recognition. And strangely, it's exactly what the name says. It's a solution that uses optical analysis, literally of pixels on a page, to perform recognition of different characters. Now, our brains do this without us even realizing. But if you look at a page and you see a collection of different dots or lines on a page, and you think to yourself, well, that looks like a 0, then that's exactly what happened in your brain. And this is exactly how optical character recognition works. Essentially, it's an algorithm that looks through all of the clusters of dots and lines and different patterns on a page and tries to make sense out of these dots and patterns and tries to put them in the different categories of what we would call different characters. Now, today it's quite common that you could go and buy a printer from your local retailer for only a few $100, and it would come with its own optical character recognition software. And for a very long time, people thought that this is the holy grail. The moment that you can do optical character recognition, well, then you're home free. You can digitize and you can automate all of your documents. But the problem with that is that understanding what characters exist on a page does not create the full picture. I want to use the analogy that you have got a small child, let's say 3 or 4-year-old child, which with you can communicate and you can teach them the different characters, numbers, letters, etc. that you can find on documents. Now you teach them to identify those characters and mouth out the characters. If you give this child, let's say, an invoice and you say, please identify the different numbers and characters on this invoice for me, surely they'd be able to mouth out A, B, C, 1, 2, 3. But this does not mean that they actually understand what this document is, what's going on in the document, what is the purpose of the document, or what is the value that this document is trying to convey. The matter of the fact is that all of these document automation solutions started with optical character recognition as the foundational technology. Now, the first optical character recognition technologies that came into existence basically worked on a zonal identification system. This means that a page, if you look at it, is divided up into different zones. Now, when you receive, for example, your municipal invoice at the end of this month, I want you to take that and look at it. And you'll see that there's definitely different zones on this document where a specific number is always going to be found. So let's say that it's important for you to be able to identify the account number. You can look at, for example, the top right-hand corner, and you can say 10% down the page and 5% to the right-hand side of the page. You can create a zone that's roughly 0.5 centimeter high by 5 centimeters wide. And within that block, if you give just that piece of paper to an optical character recognition solution, it would be able to identify your account number. Now, optical character recognition solutions, although being a very old technology by now, still has some great use. The areas where it's found incredibly good use is where a document layout is extremely fixed and it never changes. Examples of these could be official government forms. If you go to the local government office and you fill in a document for a new passport or a new identity document, these are pre-printed forms that have blocks for characters to be filled in, and it's always in the same place. You'll even notice the next time you do this that there's alignment squares on the corners of your document. So if you can find these alignment squares and you give that to an OCR solution, then it can very well spot where to find different characters on this document. The problem with this is that the invoices, the statements, and all of the other documents that we use in business in general don't follow these rules. They convey the same kind of information, and yes, you can say that they generally follow the same structure. It's very uncommon to find a VAT number at the bottom of an invoice, but there's no hard and fast rule of exactly where on a document you'll find these different fields. So the next iteration of solutions that the OCR fundies came up with was templatizing these different layouts. So let's say that you are a business that deals with only 5 suppliers. That means that in a best case scenario, you'll get only 5 invoice layouts. Now, if this is in fact the case and nothing changes, it means that you can go and train your OCR solution on these 5 layouts, and it should be to a reasonable level of accuracy be able to identify these different zones and where to go and pick up the different values on that invoice. The problem is that in reality, we are not businesses that deal with 5 suppliers only. We deal with 100 suppliers, maybe 1,000 or 2,000. In addition to that, these suppliers tend to change the layouts of their invoices. Sometimes a document comes in with a very skew scan. It might be flipped upside down. And the moment that happens, these OCR solutions completely go out the window. Luckily, technology progressed whilst OCR solutions were in play, and machine learning and neural network artificial intelligence came into play next. Now, essentially, machine learning and neural network artificial intelligence, besides that we're not going to go into the intricacies of how the technology actually functions on a fundamental level, was used in combination with optical character recognition to improve the performance of solutions that aim to digitize and automate document extraction. Now, that's a very complicated way of saying that you first run a document through a OCR solution, and then you give it to some rudimentary machine learning algorithm that understands that text can shift around, that stuff can come in different sequences, and then it can still make sense even if there's layout changes. So machine learning and neural network type of artificial intelligence topologies really ushered in the era of what we truly now call intelligent document processing. Before that, it was just very templatized and zonal, but with ML came true intelligent document processing. There's a lot of organizations that still run on classic machine learning and neural net intelligent document processing solutions. And this works especially well where you've got very straightforward document types. Let's say invoices, credit notes, statements. These are documents which differ in structure, but they've also got a very well-defined structure. Now, the ceiling of performance of classical machine learning and neural net IDP solutions come in where you start to deal with other types of documents that also become relevant. Imagine for a moment that the invoice that you receive is only the financial amount that needs to be registered in your system, but the real information, for example, the schedule of goods that you bought, the list of items that need to be delivered, is all attached in additional supporting documentation. These could be shipping documents, packing lists, bill of ladings, registry of assets, whatever these additional types of documents are that come with your legal document like the invoice, actually carry the information that you might want to record against your asset master in your ERP system, or it actually contains the different line items that you want to register on this invoice for the reasons of, for example, general ledger or cost center cost allocations. If we look at other types of use cases, so if we jump over to insurance as an example, you might deal with any and all types of documents. These might be assessor reports, pictures of the actual incident, claim forms from different brokers in very bad handwriting. And the moment that you start dealing with these complex document types, then normal machine learning IDP solutions hit the ceiling. Now, fortunately, again, the technology sector weren't sitting on their hands while machine learning technologies were being put through their paces. And the biggest revolution that's happened in this space in the last few years comes in the form of generative predictor text solutions. So we call them large language models, or we call them GPT, Claude, Gemini, whatever the personal pocket assistant is that you carry around and you go and ask, can I drink these headache tablets with this bottle of wine as you walk into the restaurant? The big fallacy is that everyone is now walking around with an extremely powerful AI right in their pocket. and you might end up convincing yourself that this on its own is an IDP solution. The problem is that it's really not an enterprise grade or scalable IDP solution. Firstly, large language models like these ultimately work on text, and they ultimately work on predicting what you want to hear out of a question that you might have asked it. It's as simple as that. That's what these models do. They go, take an input that you give it, and predict what is the correct output. So although you might ask it a question and think that you might get reliably good responses, this is not something that can really work in the enterprise or that can scale to the level that organizations need reliably functioning solutions. The second point here is that your GPT, your Claude, Gemini, Grok, they can't actually really read documents. So I know you're going to say, but I just uploaded an invoice to my GPT whilst you were talking. I've asked it what the invoice number is, and it gave it back to me reliably. What has actually happened there is that the proprietors of that technology have latched on a OCR solution in the form of that little plus button in your app. So the moment you click on that plus button and you say, take this invoice, it takes the invoice, it does as good a job as it can for OCRing that page. And then essentially it's like reading out what is legible on that document to your GPT solution and then asking it questions about that. Now, is it incredible? Absolutely. It's a massive game changer. But the bottom line is that these GPT style models still need to be used in conjunction with really good OCR technology, other techniques like de-skewing, image clarification, buffering, and then in a lot of cases, you still need your classical machine learning models that are really good at things like tabular extraction to be able to combine all of these things into a holistic solution that can give you good IDP outputs. The modern IDP stack, as organizations start to use it today, has come a really long way from the early starts that we saw with OCR, or even just the solutions that use the combination of OCR with machine learning. We now have got full reasoning stacks that's got really good digitization engines. They've got really good ability to read tabular information. So I'm talking about reading full annual financial statements from any kind of organization without pre-training, reading bank statements, reading full legal documents, reading any kind of complex business or financial document, and then producing quality outputs into your system. The bottom line, however, is that these IDP solutions need to live in enterprise-grade frameworks, because you can go and load your City of Joburg municipal bill into your GPT now, ask it a few questions, and be pretty impressed with the results. But the problem is, if you start loading 100,000 of those into your GPT, and it makes very subtle mistakes on 30% of them, then you've built an impressive demo, but something that can't scale in production. So today's story or episode, we're going to conclude with a fictionalized story about Michael. And as we go through Michael's career, hopefully it will resonate how the evolution of OCR through ML, through Gen AI, has built up this history, which gives us IDP solutions that are truly impressive and incredible in terms of what they can achieve today. Michael has worked in accounts payable for 18 years. He started when invoices arrived in brown envelopes, real ones, stamped, folded, sometimes coffee stained, sometimes faxed. When he started, automation meant a better scanner. And every year since then, someone has told him, don't worry, we're about to solve invoices. This story is really about Michael, because perception in enterprises don't live in white papers. It lives in departments like these. Last episode, we spoke about agentic AI, systems that can work towards goals. And we introduced the unified cognitive kit: perception, reasoning, planning, action, and collaboration. This story is about the first piece, perception. Because before any system can reason about fraud, optimize cash flow, plan working capital, or execute approvals, it has to see what Michael sees. And what Michael sees is documents: invoices, credit notes, statements, contracts, remittance advices. So let's rewind the story of document processing through the eyes of someone like Michael and the engineers who tried decade after decade to make his life easier. Long before Michael started in accounts payable, engineers were trying to teach machines to recognize printed characters. In the 1920s and 1930s, inventors like Gustav Tauschek were filing patents for reading machines. The ambition was simple: can a machine convert printed characters into something usable? By the 1950s and 60s, OCR matured enough to be commercially viable. Not intelligent, but practical. Fast forward to Michael's early career. His company installs an OCR system. Suddenly, instead of manually typing invoice numbers into SAP, invoices are scanned and read. Michael remembers the first time he saw it. He thought it was magic. The scanner whirred, the system spat out text, invoice number, supplier name, and total. Pixels in, characters out. For a while, it genuinely helped. Search became possible. Archives became digital. Retrieval became faster. Michael no longer had to dig through filing cabinets. But then reality hit. A supplier changed their layout. A scan was skewed. An invoice was low resolution. OCR still extracted characters, but it didn't understand the document. It captured the wrong total, it missed a decimal, it confused the 5 with an S. And when Michael posted that invoice and finance reconciled the books at month end, something didn't match. OCR gave literacy. It did not give comprehension. And that was the first illusion. Engineers hate unpredictability, so they responded the only way they knew how: control it. Templates were built. This supplier's invoice always looks like this. Define the top right zone as invoice number. Define the bottom right zone as total. Anchor. Put an anchor on invoice number. Use a regular expression to match VAT formats. For a while, Michael loved it. Straight-through processing increased. Less manual capture, more speed. But then the supplier redesigned their invoice, or expanded to a new country, or changed branding, and the template broke. Michael started noticing a new pattern. Every time something broke, IT added another template, or another rule, another exception. Soon there weren't 5 templates, there were 50, then 200, and then the dreaded share drive called Invoice Templates Final V6 Real Final. And the small wins were real, but the system became fragile. And the fragility showed up in Michael's day. Invoices that should have posted automatically started appearing in exception queues. Month-end pressures returned. Template logic didn't scale with supplier diversity. Something changed. Machine learning models started being applied to document processing. Instead of defining coordinates, engineers trained models on examples. Instead of saying invoice number is here, they said, learn what an invoice number looks like. This was built on decades of research. From Rosenblatt's perception in the 1950s to neural network advances in the 80s to the convolutional networks like Jan LeCun's work in the 1990s on the bank check recognition machine. But Michael didn't care about papers. He didn't care about these technologies. He cared about results. And suddenly, invoices from new suppliers worked without new templates. Classification improved. Confidence scores appeared. That was new. The system didn't just say, here's the total. It said, I'm 90% confident. And that changed operations. High confidence invoices posted automatically. Low confidence ones went to Michael. He wasn't typing everything anymore. He was reviewing the uncertainty. Throughput increased, exception queues shrank, and it felt like progress. But then again, something else happened. Invoices now started coming in packs, with contracts attached, with statements attached, supporting documentation. And while extraction was good, the questions got harder. Does this invoice exceed the contract cap? Does the VAT reconcile? Is this supplier's bank account different from last month? The system extracted fields, but it didn't reason across fields, across history, or across documents. It couldn't detect subtle anomalies. Michael still had to connect the dots, and that was the ceiling of this technology. Now, let's zoom out beyond accounts payable. In insurance claims, adjusters review packs of documents. In finance and banking, KYC and onboarding teams review identity bundles. In fraud, investigators compare narratives. The complexity shifted from single document extraction to cross-document reasoning. Michael saw it too. Duplicate invoices submitted with slightly modified invoice numbers, bank account changes hidden in updated supplier forms, invoices just under the approval thresholds. There's patterns. The patterns lived across documents. Machine learning extraction was strong, but judgment still lived with the humans. And then came the Transformer Revolution, or GPT. In 2017, a paper was published called Attention is All You Need, and this introduced this GPT transformer architecture. Michael didn't read the paper, but he saw the result. Suddenly, there were demos where AI could summarize invoices, compare narratives, and explain discrepancies. Himself, he uploaded an invoice to GPT and asked it, "What is the invoice number?" It answered correctly. He asked, "Is VAT calculated correctly?" And again, it answered confidently. This felt different. Not pattern matching. This is reasoning. But something bothered him. There was no confidence score tied to these deterministic postings. There was no integration into SAP, no duplicate detection against history, no segregation of duties or audit trail. It was a brilliant assistant, but it was just that, an assistant and not a system. And that's where the second illusion appears, because people started saying, "We have GPT, we don't need IDP." Michael knew better, because he lives with consequences. If an invoice posts incorrectly, it's not a demo failure, it's a financial control breach. Today, organizations that are serious don't treat IDP as one model. They treat it as a stack. Perception. This is where OCR and layout-aware extraction comes in. Structure. This is where schemas, normalization, and formatting come in. And then reasoning. This is where LLM, or large language model, comes in. But very critically, it needs to be bounded with guardrails and context grounding. And then finally, a validation layer, which is a set of deterministic checks against certain things like totals, VAT, duplicates, etc. Don't forget the governance aspect. This is thresholds, approvals, segregation of duty. And finally, like we spoke about in the last episode, enterprise-grade orchestration. This is routing between people, systems, states, bringing the human into the loop. So when this stack is engineered properly, Michael's world changes meaningfully. Invoices post straight through at scale. Exception queues shrink. Fraud signals surface earlier and month-end pressures reduce. The system is accountable, not magical. So here's the myth. Any guy with GPT can do IDP. Michael knows that that's not true because he's seen every era, from OCR through the template era. He's seen ML come and mature, and now into generative AI. Every era brought small wins, and every era created new challenges. The difference now is not that GPT exists, it's that we finally have reasoning that can sit inside a properly engineered stack. GPT enhances reasoning, and IDP strengthens perception. But without these other things like validation, orchestration, and governance, you don't have industrial document processing. You've got theatre, and Michael doesn't want theatre.
Welcome everyone, and thanks for joining episode 2 of the Agentic series. Also a big shout out to Fani for sharing such knowledgeable information around the topic. What we can do now is hop into the Q&A. So if you've got any questions regarding the topic or anything Agentic related, you can just drop it in the chat. I do see there is 2 options. There's a chat and a Q&A, so you can drop it in either one. I'll have a look at both. See who's gonna pop the first question. Oh, a bunch of them came through. Okay, so Sia says, outside of accounts payable, where do you see the most immediate impact for modern IDP, especially in industries like insurance, banking, and KYC, where documents complexity is high?
Right, thank you very much for that question. I think that we are still finding the bounds and the opportunities in terms of where document processing can now start to live. IDP based on traditional machine learning models very much bound us to fixed structure kind of documents. We're seeing a lot of growth, for example, in the legal sector, where a contract has got structure, it's got meaning, but it doesn't have a fixed structure. And it's only the new technologies that's starting to dig into that. We're also seeing a lot of growth in the logistics space in terms of supply chain documents, bills of lading, warehousing documents, these kind of things. But then also a lot of the supporting docs that was previously completely impossible just to extract from. But the reality is, I think the growth is going to be across all departments, including HR, legal, supply chain, manufacturing, sales, and everywhere in between. Thanks.
Another question from Amir. He says, what are the practical gaps between uploading an invoice into GPT and running a fully fledged engineered enterprise grade IDP stack?
Thanks for that question. Okay, so I think it's extremely hard to convince someone that's gotten really good with GPT that it can't do absolutely everything, especially with this document upload button that you've got now. And I think the second thing that makes that conversation difficult is that ultimately in the agentic space, there's a level of large language models that we also use. So you can go and make the argument, but you guys use it, so how's it different if I put something in my GPT? The reality is that the large language models that get used in the enterprise are firstly grounded in very specific context. So they are set up different to your general purpose GPT that you get to use. These models get told what kind of role or persona they have to take in. But secondly, we never set up one single LLM. We set up teams of different agents, teams of different actors, and one might do a very small step, just find an invoice number, and that might be followed by another one that audits that previous step. So it's all around how you set these things up, and that really only comes with a framework, an enterprise grade framework that gives you all of these things like guardrails, auditability, governance, orchestration, etc.
Then another question from Carl. He says, hi guys, you mentioned patterns like duplicate invoices and subtle bank detail changes. How does combining strong perception with reasoning material improve fraud detection compared to legacy automation approaches?
Right. And also, how does it compare to what your humans are doing today? Now, I think the first thing there is that these things have always existed. It's not a recent scourge or a plague. It might be on the increase, but the fraud modalities in business has always been around. Secondly, you technically could have always trained the people dealing with paper to go and spot those anomalies. The problem is that humans have got a limited set of memory and also a limited attention span and also limited time. The difference is when you get to IDP solutions and agentic, you can build so much more into the same agent that's now taking on, for example, document processing than what you could with your human. Now, not taking away from the human, they've got great other aspects. They love their kids, they look after their family, they are great people to be around. But if you give a human 1,000 invoices to process in a month, they can barely get through reading invoice numbers and values to type into a system. However, if you give this to an agent, you can make the list of things to check almost endless. And this can include, for example, basic SaaS checks to see that this is a valid invoice. But more importantly, you can say, check every invoice's bank account details, then go back in the archive and check the previous 5 invoices from the supplier to see that all of the bank details still match. Totally something that a human could also do, but not within a human's capability in terms of time, etc.
Yeah, it's a game changer. And then we've got another question from Terrelia. He says, in real enterprise environments, where does OCR realistically stop being sufficient, and where does true IDP capability actually start to matter?
Yeah, absolutely. So I would say that there's a lot of organizations out there that's still trying to sweat the investment that they've made into OCR. The reality is that these things were bulky, expensive, and very big investments when they were new. And unfortunately, technology moves at an incredibly rapid pace. And it's a very difficult write-off for some CIOs and executives to say that we've got to move on to the next technology. So firstly, I would say in a lot of cases where OCR is being used, it probably shouldn't be. A good ratio to look at is the amount of effort that you spend on maintaining your OCR solution versus the amount of effort that it's shifting away from humans. Often you'll see that you're deploying as many people to just keep up templates as you have removed from the process to actually capture invoices. However, having said that, there's limited use cases, for example, in government, home affairs, universities that can still put out very fixed form kind of exam papers. These kind of documents that are so fixed in structure that there's absolutely no imagination left to the person that's issuing that document, their OCR solutions still work decently good. For everything else, I would say IDP or Agentic.
Julian says, in real-world enterprise scenarios, documents rarely arrive alone. So how does a modern IDP stack reason across invoice packs, contracts, and historical records instead of treating each document in isolation?
Spot on. And I think that this was also maybe to an extent a shortcoming of true IDP is that it wants to firstly split document packs, and it's very proud of doing so successfully. And then it wants to deal with those documents individually. Now, the difference between pure IDP and agentic is that agentic very much takes a case mentality. So see it as 2 groups of people in your back office. The one, let's not call out specific groups, but they want to only see one specific document at a time. And as much as you can tell them the information that you need actually sits on another JSON document, they'll tell you, I've got so-and-so role, this type of training. I'm trained to look at this document, and if it lives on another document, then I'm not going to look at it. Now, you can take that hard stance, but the problem is that's not real life. And so essentially, you just professionally create more exceptions than successful cases. If you look at a different mentality, let's call it maybe an investigator, an auditor, that type of mentality, they never want to see a document in isolation. They are always looking for supporting documents. And this is where the agentic shift comes in. Although it's still really good at taking in large document packs, splitting it up into exactly the different types that you need, it then recombines them and reads them as a whole. It can go back to previous cases. It can cross-correlate between fields on a document, between fields, between documents and between packs. And that's really important.
Yeah, what a difference. Question for Mariti. What does it take for an IDP solution to move from high extraction accuracy to true operational reliability, particularly when exception handling, governance, and ERP integration are factored in?
Yeah, I think everything starts with a perfect spec up front. And I've never, ever seen one or created one myself. So in the absence of a perfect spec up front to which you can build, it takes process maturity. And so the reality is with IDP, with Agentic, etc., you're going to get a certain hit rate in the beginning. But as you go along, at scale and at speed, you're going to learn things about your own process. Up front, you might say, you know what, we never, ever get an invoice without a PO number. We never, ever get values on our invoices that don't match to the amounts on purchase orders, etc. And the solution can be built that way, but you're quickly going to learn that that might not be the reality in practice. Now, when that happens, that's not a failure on the spec, that's not a failure on the technology, but that should be banked as a learning. There should be this agile mentality around we are getting this technology to a level of maturity. And as long as we're not moving backwards or spending excessive effort that's never going to be recovered in the forward movement or the progression of this model, then we are still winning. And it is a constant journey. But generally, after 3 months to 6 months, these things tend to hit a very good level of maturity.
And then just a question from me. Looking ahead 3 to 5 years, how do you see perception capabilities evolving, and how will that change the way agentic systems operate inside enterprise workflows?
So I think that the level of OCR is at a very, very mature state. We didn't speak about it extensively today, but the sibling to OCR is called ICR, which is in all of these solutions. We just don't say that word. ICR standing for intelligent character recognition as opposed to optical. That's the models that deal with things like handwriting. Now, we've tested out a few of the ones that's out in the market today. And trust me, you will struggle to read the handwriting on a page, and then the ICR model will extract that perfectly. So those things are all good and equal, and to the level of what we can get from a page, I think we are at such a mature stage. I won't call it a ceiling. I struggle to see how we're going to get beyond that. I think the things that are still now only being uncovered is where humans have made something shorthand to read, but very difficult at the same time. And so the examples there is when you deal with, for example, logistics documents like sizing grids in the fashion industry, it's a very complicated, essentially pivot table of numbers that make up essentially a much larger document if you unpivot it. Now, the perception capability is there, but before you combine it with agentic, it really couldn't do anything to it. Some other things that are happening out in the market is you can now suddenly give an agent 3 or 4 different OCR and ICR models and IDP models and say, you as an agent have got the goal to get all of the values correct from this document. So use the tooling, these different OCR and IDP models, go and look at the document and use as many or as few of them as you need to, but get all of the information correctly. And that's also yielding an amazing set of results.
Wow, thanks, Fani. Question from Archie. Traditional ML-based IDP solutions have been around for years. At what point do they start to struggle, particularly when moving beyond structured extraction into cross-document or contextual reasoning?
Yep. So I think it's a rehash of a lot of the points that we've made now previously, but if you've got very tabular kind of documents, statements, invoices, things of that nature, IDP solutions still can do the job. But I think traditional IDP solutions should not be thrown away, they should not be shelved, but they should in future be seen as the tooling for agents. So in other words, where us as humans, we used IDP solutions to get values from an invoice or a statement, we now give them to agents. You will probably never see the raw output from that IDP solution. You will just see the output from what the agent produces. Very much in the same way that OCR is the tooling for IDP solutions. We barely see the raw output of OCR anymore. We just see the output of IDP. And the shift that I see is that we are going to ask our agents to produce that output and not directly work with IDP.
Got another question from Anza. He says, you described IDP as the perception layer in the unified cognitive kit. If that perception layer is inconsistent or accurate, what are the downstream risks for agentic system making decisions?
Okay. I think it dovetails and ties nicely to the whole theme of questioning and reasoning. So the bottom line is that perception's not perfect and that you can make mistakes at the end of the day. It's true for IDP, it's true for OCR, it's true for agentic, but it's also true for humans. And I think this is where the downstream risks need to be controlled with guardrails, segregation of duty, internal controls, and these auditing agents that I spoke about earlier. Now let's use a very silly example. If you're just doing invoice registration and some silly guy went and wrote a bunch of O's after the invoice value, your perception might be fooled in thinking that that's an invoice for R1,000,000 instead of for R1,000. Now, a human could have made that same mistake. And so if you've got no internal controls that's going to stop that invoice for being registered at R1,000,000 and getting paid at R1,000,000, then it's an internal control failure, not a perception failure.
Oh. Looks like we got two more questions over here. We'll start with the second to last one. IDP sounds very exciting. Given that generative AI models are inherently probabilistic, how do you build guardrails and validation mechanisms that make the system trustworthy in regulated financial environments?
Yep. And the finance and banking clients want to understand this intimately. Now, it's very document specific, firstly, and it's also risk-based. So if, for example, you have a list of medical documents that you are reading with your agent, and then you want to go and automatically do life insurance underwriting from that, it's probably a bad idea. And I'm sure that the FSP authority will also say that that's a bad idea. However, if you now see this differently, that the IDP solution and the agentic solution can read those medical documents and set up a proposed underwriting in a case file for someone to review with the documents adjacent to that case file, that's a whole different story. And so the bottom line is it's very case specific, but you have to make sure that it remains an assistive technology as opposed to an authoritative technology. It always works side by side with humans. It removes the grunt work and the effort from the human whilst giving them all the benefit, but the human ultimately needs to remain accountable there.
Final question from Carl. He says confidence scoring was a major shift in ML era IDP. From an operational standpoint, how should businesses design human review processes around confidence thresholds without slowing everything down?
Okay, that's great. So there's an element of a risk-based approach that also needs to reign true. Risk-based, but also success-based, right? So if you look at, for example, a purchase order-based invoice. Now, if you get the purchase order number wrong on that invoice, the chances are that you're going to try and register this against a different purchase order, which might have been consumed, might have been closed. There's a very, very low likelihood that you are erroneously going to register this invoice against the wrong purchase order. Now, that's also not the end of the world, but it will probably give you an exception. And so you might want to put a high value on getting the purchase order number right. You might want to get a high confidence score on getting the total amount right, because if that total amount isn't right, again, either the invoice won't register or you'll get a wrong amount registered. There's internal controls downstream that will stop it, but it means you have to redo this invoice. If you are registering line items on an invoice and you want to get a description of goods, a free text description into your ERP system, well, I don't think one missing character is going to change the world. If it says Coke instead of Coca or whatever the case is, the general idea is still there. And that's typically not something that's going to move the earth. So if you want to adjust your confidence scoring lower on that end, then it's in all likelihood probably okay. And the important thing is to pick a solution or a framework that gives you the ability to make that selection per field, per document type, per case type.
Thanks for that, Fani. I think that might have been our last question. Yeah, looks like it's happy to wrap up there, Fani.
Right.
Any last questions?
Right. Thanks, Seb. Thanks, everyone, for joining. This was our episode on IDP solutions. In future episodes, we'll touch on more of the other agentic tentacles that are out there. Together, we'll get to know what agentic's all about. We'll do some great demos. We'll see some real solutions in the industry in action. Thank you very much for joining. See you next time.
Thanks, everyone. Cheers.